Hello Hongbailu and fellow students. Today I'll be talking about the pollution of the Hawkesbury-Nepean River. The environmental problem. The Hawkesbury-Nepean River is one of the longest catchments in New South Wales, with a flow length of 470 kilometres. Starting from the south of Goulburn and flowing through to Broken Bay, the river is highly significant because it supplies 97% of the drinking water to many of the state's urban city centres, such as Central Coast, Illawarra, Blue Mountains, and of course Sydney. The catchment is also responsible for most of Sydney's supply of fruit, vegetables, poultry, and dairy products. Runoff from agricultural land and treated waste from the many sewerage treatment plants located in the vicinity of the Hawkesbury-Nepean River have been polluting the water for some time. These pollutants include pesticides and nutrients such as nitrogen, phosphorus, and sediment. Excess nitrogen and phosphorus can cause algal blooms to thrive in the water, which can be highly toxic to humans, livestock, and fish. Sediment can smother plants, clog fish gills, and reduce light penetration in the water, killing aquatic plants and animals that rely on such flora and fauna as a food source. In recent years, the algal blooms and excessive aquatic weed growth caused by nutrient pollutants have also severely affected recreational and commercial uses on the river due to restricted flows. The economic problem. External costs occur when third parties incur costs of which they are not party to the decision that gave rise to them. In this case, in the case of the Hawkesbury-Nepean River, external costs occur as a result of the decisions and activities brought about by the farmers and the sewage treatment plant operators, but the costs of which are incurred in part by others who place the value, of course, on the ecological characteristics of the river and the quality of its water, more specifically. The Hawkesbury-Nepean River is of significant environmental, social, and economic value to the local and surrounding communities, and therefore the extent of the external cost would be large should the water quality become further degraded. With regards to the economic costs at play, many of the businesses on the river, such as the prawn and oyster fisheries positioned downstream, will be greatly affected, as will the farmers that draw upon the water for stock irrigation crops. Recreational users of the river alike, such as hikers, boaters, water skiers, and so on, will be also repelled from the area, which in turn will greatly affect tourism. There would also be a substantial purification cost involved, which thus would add to the economic total cost. Environmental costs would be incurred as the water quality worsened as well, building up high concentrations, obviously, of pesticides, thus killing many plants and animals in the habitat and surrounding habitats. Excess nutrients such as phosphates and nitrates entering the river will cause an abundance of terrestrial weed, algal, and aquatic plant growth, reducing the flow and heavily reducing the oxygen in the water itself. This is known as hypoxia, further disrupting ecological processes that support native fish populations and vegetation. Social costs would also be incurred as the water quality worsened, as the river is a major local drinking water source. A build-up of toxic chemicals which are released from the algal bloom would plague the drinking water, affecting hundreds of thousands of people, and in turn putting pressure on the local health system or systems and its water and its resources. Policy instruments. So when individuals and firms consider external costs and make decisions about their resource use, they are inherently guided by their own incentives. Policies can be introduced by the government for the purpose of internalising such costs. Such policies affect the terms under which the natural resources can be used. The purpose of this is to create economic efficiency, which is the maximisation of net benefits to all those in which are affected by the natural resource and its use. Considering the circumstances pertaining to the Hawkesbury-Nepean River, Begovian taxes and tradable permits are two types of policies the government could facilitate to lead firms into making decisions that are simultaneously both in their own best interests and in the best interests of society at large. Begovian taxes. So just having a brief look at Begovian taxes. A Begovian tax would simply charge a fee equivalent to the amount of the pollutants in which are responsible for releasing, or a particular firm or an individual is responsible for releasing into the river. The tax would in effect become an additional cost in the production of agriculture or sewage treatment, more rather. By increasing farmers' costs, the expectation is that farmers and sewage treatment plant operators would be forced to use less pollutants, thus improving water quality conditions throughout the Hawkesbury and Nepean River. Now, in terms of tradable permits, the tradable permit is another way in which that polluters can be forced to internalise the cost of such externalities. The government would simply cap the maximum limit of a chemical concentration in the Hawkesbury and Nepean River within a specified time period, and then issue permits to firms at a price which would allow the release of an indicated fraction of the maximum threshold during that time period. In this instance, the high polluters have to buy more permits, obviously, for which can be traded from firm to firm. Firms who find a way not to pollute, or let's say not pollute as much, obviously become more profitable as they can sell those permits off, which creates an incentive for firms to reduce their level of pollution. In terms of a critical analysis of the Burgovian taxes, the problem with this policy is that the inability to determine exactly what the marginal costs of additional polluting would be. If marginal costs cannot be accurately measured beyond a certain level, then determining an appropriate level of tax for polluters beyond a certain point would be extremely difficult. Obviously, too little tax to cover the costs associated with additional output would be obviously catastrophic, whilst too much tax will cause firms to shut down and create a loss of jobs. This renders the Burgovian tax policy as highly inefficient. Burgovian taxes that are generally based on additional output of pollution from a certain baseline, and because of this, they do not take into account profitability of a firm, usually, unlike a progressive tax. Burgovian taxes could therefore fail to recognise a firm's ability to pay. This potentially creates equity problems, as poorer firms are penalised at a much higher percentage factor compared to wealthier firms. Burgovian taxes also require significant monitoring and enforceability costs, as ongoing research would need to be conducted in order to establish accurate marginal external costs associated with further pollution. Like tradable permits, information asymmetry does exist and could potentially lead to farmers and sewage treatment plant operators hiding their true levels of pollution. A common perception of the Burgovian tax scheme is that it allows firms to pollute to an uncapped extent at a price, allowing further pollution and degradation potential at large. Whilst this policy may incentivise firms to innovate, it may be more in terms of cost for a particular firm to continue just simply polluting rather than develop new technology. Political factors also play a part, such as lobbying. There could be an issue where we simply have non-polluters or anti-polluters advocating and lobbying for higher taxes, and then simply we could have pro-polluters haggling for reduced taxes. In either case, both circumstances would prevent optimal levels of tax being collected. Now, in terms of the critical analysis for tradable permits give firms a legal right to pollute to a certain amount within a specified time period. A threshold amount lower than the current concentrations would have to be determined by scientists, which allow the environment to recover on its own accord. Provided an acceptable level of pollutants can be determined, this policy has a prosperous chance of producing economic efficiency. If a firm produces less than its permits allow, it can on-sell the surplus permits to other firms. On the other hand, if a firm produces more pollution than its current permits allow for, they will have to obviously purchase more permits. This creates a market for tradable permits that could render prices to be incredibly expensive, where there is a large number of polluting firms and only a small number of permits available. Such an environment could allow for powerful firms to outprice new and existing contenders to the market, creating a monopoly or an oligopoly, leading to market problems. Now, if tradable permits can be kept perfectly competitive, then a tradable permit scheme would obviously be highly economically equitable. A tradable permit scheme would require some monitoring and enforceability costs, obviously. However, the cost of acquiring the information required would be substantially less than a Begovian tax. Information asymmetry could potentially lead farmers and sewage plant operators into heightening their true levels of pollution, as would the Begovian tax scheme. A common perception in relation to tradable permits is that they give polluters the right to buy and sell the right to pollute. Once the pollution threshold and trade system is in place, polluters will have additional costs associated with emitting fertilizers and nutrients that typically cause the problems. This is also, not only is there a guarantee that the total level of pollution will not exceed the limit, unlike the taxes, there is also an associated incentive for firms to develop innovative technology that would lead to being able to draw profits from the sales of surplus permits, which is obviously a massive plus. So when we consider the positives and the negatives of both policies, in the end, I've sort of been swayed towards the tradable permits, and primarily because, given the extent of the issues pertaining to the lack of the efficiency and equity achievable by the Begovian taxes, in this instance, a tradable permit scheme would be recommended as the policy of choice. Most importantly, the policy offers a guarantee that the total levels of pollution, namely nitrogen and phosphorus, will not exceed a certain limit, unlike Begovian taxes. The associated saving and potential profit drawn from the sale of surplus permits would also lead to the development and innovative technology that may spill over to other stakeholders and lower the external cost to the society abroad. That concludes my presentation for today. Thank you for your time, and I hope you enjoyed. Cheers.